Okay. Good morning, my friends. Mr. Nelson here from the 403 to the HAZ. Here we are. I'm put on my glasses because my eyes are sore this morning. Tired. Nope, they're dirty. Not gonna do that. Okay, I'm just gonna rub the sleep out of my eyes. Here we go. Good morning. Here we go. Here we go. Here we go. Here we go. So, we have been talking so far in our exponents unit, or radicals and in our radicals and exponents unit. We've been talking about just the different things you can do when you have expressions that are multiplying each other. So in this case, we learned that I can just take x and add the x exponents, and take y and we'll add the y exponents. Sorry, yeah. So this would give me, 2 plus 4. 2 plus 3. I totally biffed that one. So x5, y to the 6. It's all fine and dandy, right? But something changes as soon as we introduce a plus sign in between those two numbers, times x cubed plus y4. These are what we call, each of these is called a binomial. Bi means two, nomial means number, probably. So these are binomials, and they're binomials because there is an addition or a subtraction operation that separates them. So binomial, binomial. Now, what happens when these two things get multiplied together? Well, we can't just go through and start adding exponents and doing what we've been doing so far when it's just been multiplication or division. Now, we do something called distributive multiplication. So now what we have to do is we have to take this x squared, and it has to multiply by this, and it also needs to be multiplied by this. And there's going to be an addition that separates those. So that part looks like this. X squared times x cubed plus x squared times y to the 4. But we're not done yet, because we still have this y squared here. So this y squared now has to go next door and also multiply by the neighbors. So then there's also going to be an addition here that separates them. So plus y squared x cubed plus y squared times y to the 4th. So that is what this becomes. However, we can simplify this a little bit, because over here we have two x's, two bases of x, and over here we have two bases of y. So those we can actually add the exponents because they are multiplying each other. So this ultimately becomes, well, x to the power of 5 plus x squared y quad, or to the power 4, plus y squared x to the power of 3 plus y 2 plus 4 is 6. Okay? So as you can see, it gets a little slightly more complicated, I suppose, because now we're using what we know about adding exponents when they're multiplying, but now we have more multiplications to do, and we have to kind of separate each part of the expression there. My language skills not so good this early in the morning. Actually, let's have some coffee. Just a small cup. I asked for an espresso, they gave me this. Okay, so this brings us into our polynomials unit. And the first part of this unit, we're just going to learn about multiplying polynomials. Okay, so there are binomials. You'll hear the term binomial. And you'll hear the term polynomial. And And the most common polynomial that we'll work with, at least at this level right now, generally speaking, is a trinomial. Try for 3, so 3 terms. And then binomial just means that there's 2 terms. So here are some examples of some binomials. X minus 1, y plus x, y squared plus y. Okay, they don't have to have the brackets, I'm just giving the brackets because I'm fancy. X squared y plus 2x. Basically there's just one addition sign, that's what, or subtraction. So I could also, I mean, sky's the limit. We could go p squared q squared minus q. Okay, these are all binomials, two terms separated by one operation sign. Okay, trinomial or polynomial, well, they look something like this: x squared plus 2x minus 3, or yx cubed plus xy minus 3x. Y to the power 4 plus x squared y squared minus x to the power 4 plus x to the power 4. Okay, so now we have 2 operation signs separating 3, in this case 3. So these are trinomials, and then polynomials could be anything like x4 plus x squared y squared plus x cubed plus 3y minus 2. Okay, this is a polynomial. It's got more than 2 terms separated by addition or subtraction operation signs. Okay, so now that's that. So these are, so you know, what this means, as I erase these, is something like x squared y cubed z 4 x cubed y squared. Okay, all multiplied by each other here. So while I could, so this is very different from, say, something like this: x squared plus y squared times z to the 4 plus x cubed y squared. Okay, well, let's just put a negative in there just to change it up. Okay, so these two are going to play out very differently because these signs change the game. So while up here, because it's just one long multiplication, I can use my product, I don't know, is it product law? One of my exponent laws, to add 2 plus 3, 2 plus 3, y, 3 plus 2, z to the 4. So this would work out to x5, y5, z4, okay? This, on the other hand, we have to treat a little differently. So what we need to do is we need to start with our leftmost term in our leftmost bracket. So I take this x squared. He jumps to the other side, to the other bracket, and multiplies by the first term, and then the next term after the next operation. So he doesn't go in and multiply by x cubed and then y squared. He just hits the whole term that's separated by this. So if I had a plus x here, well, then he would also come through and then multiply by the x here. Okay? So what does this look like? And then once we've done that, then we have to come through and we have to do the next term. I mean, it has to multiply by there, and then by there. Okay? So how does this play out? Magically. It plays out magically. Darn markers. So let's use red. So this becomes, we'll use blue. So x squared times z to the 4 is just x squared z to the 4. Now, they're multiplying each other. I'm not going to put the little sign between them because you don't really do that in practice. So it's just z squared z to the 4. X squared z to the 4. These are multiplying each other. down, x squared, z to the 4. Plus, or sorry, minus x squared times negative, so now I have negative x2 plus 3 is 5. Well, I guess I can show it like this first. x2, x3, y squared. And then I do my y plus y plus y squared z to the 4, and then it's plus times negative, so minus y squared x cubed y squared. Now, I'm almost done, but I'm not quite done. The next thing I need to do is just make sure that I simplify each term here. So there's no repeating variables here. Here I have two sets of x's. One's x squared, one's x cubed. So I can rewrite this in its final form as x squared z to the 4 minus x2 plus 3 is x5 y squared plus it's just y squared z4 minus y, two sets of y's and both squared, so 2 plus 2 is 4 x cubed. Okay, and now I look, are there any sets here that are exactly the same? No, there's no sets of combinations here that are exactly the same. If there was, I would collect them and combine them. Just like if I had 2x plus x plus 3x, this would add up to, you just count the number of x's. 2 plus 1 plus 3 is 6x. In the same way, if I have x squared plus 3x squared plus x cubed plus 2x squared, well, I could rewrite this. I could collect all my x squared terms and just count them up. So I have 1, 2, 3, 4, 5, 6, 6x squared plus x cubed. And just like that, if I had, say, x squared, y squared, minus 2x plus 3x squared y squared plus 2y squared x squared. Well, I have an x squared y squared term here. I have an x squared y squared term there. And this I could rearrange to be x squared y squared as well. So it's the same. So I could rewrite this as 1, 2, 3, 4, 5, 6. 6x squared y squared minus 2x. Okay, so I can always collect exact groups of the exact same expression within a polynomial. So let's do a few examples here to just round it out. So we are multiplying polynomials, which takes advantage of what we know about our exponent laws. And that's why, and you'll end up using this so much. So where we go from this is, once we know how to multiply polynomials, then we're gonna combine what we've learned about factoring and factorization to start now factoring polynomials. So we're gonna go from the end result that I was showing you back to the bracketed initial starting point. We're gonna learn how to go from one to the other. Factoring, you're gonna learn to love it or hate it. No, I think factoring's just like puzzle solving, it's good. So, here we go. So let's do some examples of polynomials and binomials. So let's start basic. So let's start with a monomial multiplied by x squared plus 3y. Okay, so because there's an addition sign here, this guy now has to distribute evenly into each term separated by the operation. So this becomes x squared plus 3x squared y is x to the 4, 2 plus 2, plus 3x squared to the y. So right now, while we're kind of starting out, I'm going to always just write out the full expression as it happens. As you get more experienced and advanced, you're going to look at this, be like, okay, I have x times x, okay, that's x to the 4, 2 plus 2, 4. You'll go straight to here. But I'm going to add that extra step along the way just to show. So that's done. Okay, so the x multiplies, so there's an invisible 1 that multiplies by the 3 here, and then we just collect. So what if I had 2s cubed times 3s minus 4t. Okay? Well, again, this goes through and multiplies here, and then this goes through and multiplies here. And what do I get? Well, first, 2 times 3 is 6, and then s3 times s is s3s. And then minus 2 times 4, 2 times 4 is negative 8, and then s cubed times t. And so I can simplify this as 6 s to the 4, 3 plus 1, minus 8 s cubed to the t, or s cubed t. Okay, so these are monomial binomial operations. So let's get a little bit more complicated. What if I had s squared minus 3, so binomial multiplied by a trinomial. S squared plus 4st minus t squared, we'll say. I'm just pulling these out of the air, so see what happens. So again, I start with my first term of my first bracket, and I say, okay, you're gonna jump in there, jump in here, and then jump in there. And then my next term on the left bracket is going to start here, then go here, and then go here. So s squared times s squared is s squared, s squared. And then plus 1 times 4, s squared, st, minus s squared times t squared. And now let's do the blue. Minus 3s squared. 3 times 4 is negative 12 times st. And then negative times negative is a positive, plus 3t squared. Now I'm going to look for, well, first I'm going to add any exponents that have the same base here. So this becomes s to the 4, 2 plus 2, plus 4s cubed, 2 plus 1, t, minus s squared, t squared, minus 3s squared, minus 12st plus 3t squared. Holy, look at that answer, right? Super long. Do I have any identical variables here, or expressions? No, they're all unique, so I can't do any combining here. Okay, so this is my final answer here. Let's do a couple binomials multiplying each other, a couple more, because we'll end up seeing those quite a bit. So let's say I had x minus 3 times x plus 2. Okay? If I multiply these out, I'll start with the x here. It's going to multiply here, and then multiply here. And this 3 is going to multiply here, and multiply here. So if I do this exercise, I get x times x is x squared. I'm going to skip that step of writing them both. So 1 plus 1 is 2, x squared, plus 2x, minus 3 times x, minus 3x, minus 6. Okay, and then I look here. Do I have any of the same variable here? Yeah, well I have x here and x here. So I can actually add these two sets together. So this gives me a final answer of x squared, 2 minus 3 minus x minus 6. And that is my final answer. Okay, and then let's just do one last one for funsies. Okay. let's say I had x squared plus y minus 2 multiplied by x squared plus 3y minus 6. Okay, so what's going to happen here? Oh, this is gross. Why did I do this? Why did I do this? Well, let's do it anyway. So first, I'm going to start with my first term here. He's going to come over here and dance. And then he's going to come over here and do that. And he's going to come over here and do that. Next, my y is going to do the same. I'm going to come here, going to come here, going to go there. And then little Miss 2 here is going to, purple? I need purple. I need purple. I got my purple. So 2 then is going to also multiply here, multiply here, multiply here. We're going to have a very long answer. So let's start doing it. Let's do the red. X squared times x squared. x2 plus 2 is 4, okay? I'm going to skip that first step there. X squared times 3y is plus 3x times y. And then x squared times negative 6 is negative 6x squared. Next, I have my blue. So, y times x squared is plus x squared y, or yx squared. Doesn't really matter what order. And then y times 3y is plus 3y. 1 plus 1 is 2. And then y times negative 6 is negative 6y. And then let's do the purple. And I've got negative 2 times x, so negative 2x squared. And then negative 2 times 3y is negative 6y. And then negative 2 times negative 6 is plus 12. Okay. It's all up there right now, and now all I have left to do is make sure that I don't have any repeating terms. So I could see right away that I have 2 sets of y's here. What else do I have that's repeating? Any x squared terms? Yeah, so I have x squared here, and I have an x squared here. And I have x cubed, no. I have x y's, any other x y's? No. X squared y's? No. And y squared. So I can combine my circled ones together. So this, I'll bring this down. So I have x4 plus 3xy minus 6x squared minus 2x squared is minus 8x squared plus x squared y plus 3y squared. And then, so I took care of this guy, took care of this guy. Minus 6 is minus 12y plus 12. Okay? That's the final answer there. So this is, you know, I would never give you a question like this on a test. But, you know, you do need to know how to do long, complicated operations like this. And it's really just a staying organized thing, right? So as you can see, I use 3 different colors. Obviously, that's because we don't all have a whiteboard in front of you, but doing something so that, you know, maybe doing it in stacked lines. So you do your first set of multiplications, you're red there. You do the next one stacked under, and then the third one stacked under, and then you can work with it that way so you know which multiplications you've already done, because you're handling a lot of numbers here and it can get kind of complicated. But that is multiplying polynomials. And I think you're ready to fly, my little ducklings. So thank you, and I'll be back with another video soon.